everyone. So we're here with Matt Sutherlin for 343. He's a technical shader artist working on Halo 5. So why don't you tell us a bit about what you've done on Halo?
Oh, okay, sure. Yeah, pretty much I write shaders. So all over the place, anything that's surface shading, so I don't do a lot of like the effects of particle systems and stuff. That's somebody else, although I help a little bit. All the UI stuff, so not only front end menu stuff, but like runtime, like HUD wires, ammo counters, things like that. But yeah, surface shaders, so all the terrain shaders, pretty much if it's shader stuff, I probably have a hand in it somewhere.
Okay, cool.
Yeah.
So how was that transitioning to like a full-on just shaders from like working on DigiPen projects where you were probably more involved in like all of the graphic stuff?
Right. It's interesting. Like, in ways it was good, in ways it was bad. When the job originally came up, it seemed like a weird fit because I'm not an artist. I mean, I know the job of a tech artist, like the tech artist title is a real catch-all to like describe anybody that kind of straddles skill sets that they don't otherwise know how to name. So there are people that are very, very art-driven with some, like people basically that set up like rigs in Maya, and they're tech artists, and like me, and I don't make art, right? So, but it still seemed like a weird fit. But honestly, during my time here at DigiPen, one of the biggest gaps in what you can really experience is working with a good variety of artists that that are going to ask things of you and not be okay with an answer that I don't have time for that, or I can't do that. So I spent a lot of time at the school, learning C++, diving into graphics APIs, learning how to build a renderer, but at the same time, that was kind of boxed into what I thought was a good idea, and had very limited exposure to how do artists use it, what will they try to do with it, how do I guard against it or extend it to let them do that. So I actually saw the job as a good way to fill in probably the biggest gap in my learning at school. And then the actual work, so in ways, it's a little sad. Like 2 years later, I feel like I'm getting a little rusty at C++. Like I used to pretty much know like the DirectX 11 API from memory, and now there are definitely gaps. On the other hand, though, providing just the shaders, like not having to provide a complete end-to-end feature set is amazing. I don't have to figure out how, once we compile it, it's usable by content, it shows up in Maya, it also shows up in the game, and as I write different permutations of shaders, all the texture and value parameters, I don't have to worry about that. That all works, or if it doesn't work, somebody else deals with it. Which kind of goes into it's made me worse at some things, but it's an incredibly freeing experience to have to only work on a very small subset of things. It lets you dive pretty deep, though. So.
Okay. And so one of the things you mentioned was that you get to work a lot more with artists, which I know is something a lot of us here wish we could do.
Yeah.
They're pretty scarce around here. So what are some of the things that you do for artists that they find are really useful that maybe you didn't have time for at DigiPen, or didn't have the technical expertise, or would have been nice to know about?
Well, sure. So, and in general, kind of the general thing that a tech artist does is I'm the person that acts as a buffer between engineers and artists. Not that they don't ever talk to each other, but I'm sure if any of you have actually worked with artists on your projects, there's always going to be a disconnect between an engineer who can be very literal about the semantics of what they're talking about, and an artist who's just like, this is what I want, just make it happen. And using the same words to describe two very different things and not understanding each other and not getting anything done. Of course, coming from a very strong engineering background, I had to learn that. I had to learn how to talk to job. But I mean, that's a big part of it. Is it honestly a lot? Almost the entire job is somebody says, "Hey, I want to be able to do X." So I sit down with them, and either it's like, well, we have shaders that can do X, and we have shaders that can do Y. Can we get one that does both? And usually, in that case, that's like 5 minutes of my time. It's amazing. And then they're like, this is great. And I'm like, I know, I'm the best. But sometimes it's like, I need to make something entirely new from scratch. But it's just the process of sitting down with them, seeing what it is they really want, how they want to work with it. Because it's not just about like getting, I mean, a big part of it is visual target. It needs to look the way they want it to look. But if I give them something that can hit the visual target and they don't understand how to work with it, if they can't generate the proper content to work with it, it's never going to get used. And I can't be expected to generate content that works with it because I can't make art. So it's an interesting thing. Like if I could just, if I had the skill set to be like, this is what it should look like, maybe I could make weird, complex things that nobody knows how to use, but there's base content, everybody's just like, that's fine. But because that's not my skill set, I've had to figure out how to not think about what I would do and realize what they want to do and just make it work that way. So one of the more challenging things with the job, though, is that when I understand the vision for what they're trying to achieve, it's relatively easy. Occasionally, I could sit down, like I'll get like a 3-page email, we'll sit down and talk for an hour, and I'm like, I get it, but I don't get it. And so like I can make the thing that they asked for on like a literal level, but I don't understand really how they think that's gonna go together to create the look they're trying to get. And when that happens, the results are usually bad. So yeah, a big part of it is just talking with them and sitting down and making sure that I understand what they really want to do and in the real way they're trying to do it, so that I can make sure that that's how it works when it gets to them. Because otherwise things either look bad or just don't get used, and then it's wasted everybody's time.
Right.
None of which is stuff that I encountered when I was here. Because when I was here, it was like, it'd be really cool if the engine did X. And I was like, okay, I got it. Disappeared for like a day or two, and I came back and I'm like, this is it. And nobody ever asked a single question, right? It just worked or it didn't, and people dealt with it. I mean, I don't know, maybe that's just me, maybe that's not any of you, but I feel like that wasn't that unusual of an experience. Like, tech gets into the engine and it just works the way it works.
Yeah, our engines are probably a lot less complex here.
Well, that too, but yeah.
Okay, so another thing interesting about your transition is going from working on kind of solo projects that are just for Windows usually to working as like a first-party developer on a console.
Yeah.
So what are some of the differences there?
So working first-party for a single console platform is the best. There's a single fixed piece of hardware. Like as far as, so there's AMD provides the APU that powers the Xbox, but we write, so 343 doesn't, but somewhere inside Microsoft there's a team that writes the graphics driver. So whatever bugs exist, whatever weirdness exists in the driver is our fault, not AMD's, but it also means that there's a better, more direct possibility to fix it. It's not, I'd be lying if I said it was like 100% direct, but like if I encounter something that doesn't seem to work right, I can more or less reach out to the people responsible for that code and be like, what's going on? Why doesn't this work? Is this a bug? Am I just not using it right? Or, you know, like, since we only have one GPU that we worry about, there's a lot of functionality that GPU has that is not part of the generic HLSL standard. That's true for a lot of cards, though. You know, feature sets get added, and like OpenGL deals with it with bizarre extension wrangling, and it's like a real nightmare but hardware manufacturers put in features, and over time people start to adopt them very slowly for like one-offs, and then eventually they get worked into the APIs, and then everybody has them. But it takes a while. For us, if I see something, so like I keep a copy of the ISA for the our GPU architecture open in a tab. If I am trying to do something and I see that like bytecode level the card is capable of something, but it is not exposed in HLSL, I have the ability to be like, can you make this an intrinsic? Can I do this? It won't always be yes, but the possibility exists that if I want to do something that isn't part of the standard book, knowing it won't power for the Xbox code, that might be fine. You don't get to do that in PC. Well, the other thing is that even beyond my ability to focus that directly, I mean, the XDK itself already has a lot of very Xbox specific stuff, and you can, if you know what you're doing, you can fine tune the way that it allocates like scalar and vector register lifetimes. You can affect memory latency to really take advantage of the hardware. If you tried to do that on a PC, you would have to like individually target every single piece of hardware, or target individual pieces of hardware, and then you get good performance on these cards that you were able to target, but these one, and so you still have to hit your like worst case scenario, right? You can't be like, game runs great on these 3 cards, everybody else, good luck. You're only as good as your minimum platform performance, right? But my minimum platform performance is my only platform. And so yeah, it is, it's super convenient. So I can very, very specifically target what it's capable of, and I don't have to worry about, did I just break anything on any other platform? That's never a consideration. And yeah, nobody's gonna be like, I have this weird PC setup, why doesn't it work? Like, I've had, I've worked on AAA games that shipped on PC, and there's a box of old GPUs sitting in the corner, and then a bug comes up. Sometimes you just dismantle your PC, put in the video card specified in the bug, and start it up and try to repro it. That's reality. That's not my reality anymore.
Yeah, and that's a hard reality to deal with as a student.
Yeah. No, as a student,
students just don't have boxes of GPUs
right now.
Well, exactly. But when that, it's almost better in a way for a student project that you don't have access, because I spent a lot of time on the floor dismantling and putting together my PC to try to track down card-specific bugs. It is great when you figure out what's wrong, you can solve it, but like it's very time-consuming. And it's like the 3 people that you just fixed the bug for, I'm sure they're super stoked, and that's great, but I don't know. I don't recommend it.
Yeah. So sometimes you're in a rock and a hard place situation where those 3 people happen to be on your team.
Sure.
So do you have any tips for kind of tracking down and fixing those types of issues when they do come up, especially when it's like really critical because there's people on your team that are blocked by it?
Sure. So, the common stuff, first of all, make sure your drivers are up to date. Here's one. Make sure that everybody's video card is actually capable of the feature level that you're trying to target with the API. Senior year here, we had the great idea to set up a server in our team space to be a single computer build farm and continuous integration service. However, the computer we put together, the GPU could not run shader model 5.0. So my DirectX 11 renderer did not run on it, which was interesting. But it wasn't immediately apparent. The way that it should have failed in that case is not the way that it failed. It tried to run and then it just displayed black screen. Because you would expect it should fail validation of my shader bytecode because it's compiled to a version, a shader model that's not supported. So when it tried to load and validate them, it should have failed, and I should have crashed somewhere in that code, and it should have been able to report like the H result but it didn't. It ran. It never crashed. It just displayed a black screen. So then it took a little longer than I cared to confess, but we ended up looking up the card specs online and realizing that it only supported shader model 4.1, which is why it was so cheap. But you know, that's a thing. But making sure your drivers are up to date, making sure the video card can do what you're trying to do. You know, I don't have as much familiarity with OpenGL, but I know, like, you know, DirectX enable the debug layer. Enabling the debug layer can really help you. Junior year, one of the other teams, one of the guys, his computer crashed trying to initialize a D3D device with the debug layer. I never figured out why. Like, so it wasn't even my team, right? But they're having this problem, like, that's weird. I couldn't help them figure out why, so instead, I helped them write UAC code to detect that guy's username and just never try to load the debug layer. Sometimes that's what you do. During my internship at Blizzard, I encountered, so this is one of those times where I had to pull my PC apart and install an old-ass video card to actually try to repro the exact conditions of a bug. And that is the one time I've ever encountered a legit driver bug. But that was a funny one because that was a driver bug. So I don't know if everybody's familiar with how this works. So when you get a so like, I don't know about AMD, but I'm sure it's the same. So like occasionally I'll get a prompt from NVIDIA that's like, new driver. And then in the patch notes, it's like, these games run this much faster. And it's like, how does that work? It's because there's a team at NVIDIA that popular games, they inject a DLL into those games to analyze all of their API calls, to try to figure out what they're doing without actually knowing their source code, to rewrite a golden path through their driver for that game specifically to try to improve performance so that they can claim a 20% performance increase to try to sell more video cards. And in my case, I found out that them doing that caused them to create a golden path for StarCraft that in one case caused the Y value of a float 3 when it overflowed float max, corrupted the Z value.
Pretty obscure.
Impossible to do based on the standard, but part of what they do is when they figure out what you're doing, they'll just skip validations to speed it up. And in this case, they skipped a validation and did something illegal and wrong, and it introduced this bug. I found a way to fix it anyway, but what I ended up having to do, so, you know, back in the day, in DirectX 9, you used perphud, but I had to load the game through perphud, I had to step each frame, and then I had to go through each API call until I found the API call. I had to actually get it to give me like the shader disassembly, and I had to go instruction through instruction to find out where, like, the value comes in as a 1, it's a 1, it's a 1, it's negative 8 billion. Oh, so I had to step each instruction in a pixel shader. I had to figure out the draw call, I had to get the disassembly, I had to step that pixel shader until I found where. I had to figure out which value, where the value was coming from register-wise, and then I had to track that register until I found out where it was happening, and then figure out how that associated to our actual HLSL to figure out what was going on. And then that led me to, like, what happened was impossible. So it had to be a driver bug, but I was still able to fix the code to balance check it in that case, which should have been done anyway. So it's just an interesting side effect that we exposed it, but like, that was not a fun process. That entire process took me like a week to track down. The fix took 30 seconds, right? Sometimes, usually, hopefully, you don't have to go that far. But what will happen is, like, so for example, in DirectX, like, I know I know it's not necessarily your thing, but so when you sample a texture, it will use partial screen space derivatives to determine MIP selection, unless you're using a load command or you use one of the sample commands that takes an explicit MIP. So, if you try to call a sample command that automatically determines the MIP from partial screen space derivatives inside a branch, that's undefined behavior, technically. Now, a lot of times the driver will let you get away with that, and there are two ways that happens. Either you get lucky and it just works out, or like in HLSL, a lot of times what will happen is if you're paying attention to warnings view, it will tell you that that's illegal and that it's reordering the instruction to outside the branch. So you should probably reorder that to outside or restructure your code to not have that problem, but HLSL, GLSL, they get really tricky about letting you think the things you're doing are legal, and they are not legal. There's a lot of interesting things that are completely not legal, but that you will not get like a compile error on. Sorry, kind of took a really long, but some of them can be very insidious. Usually, if you enable all the error checking that your API allows, they can help you track it down. Sometimes it won't. Sometimes it will give you misinformation. In DirectX specifically, I'm sure you can do something like this in OpenGL, but so, most of us set up the renderer to just create a hardware device. You can also create a reference device, and a reference device is a software representation of what hardware should do, but it's based off of the standard. So you'll have to set up some stuff specific. You can't just necessarily create one code path and flip the switch between reference device and hardware device. It doesn't fully work. But if you set it up to be able to turn on as a reference device, that will follow the standard. That will be free of any driver bugs. That will be free of any weird bugs. So you can determine, do I have a driver bug? Do I have my own bug? Like, what does it look like under the reference device? That's essentially your ground truth. If it doesn't look great in the reference device, you've got problems. But you can at least eliminate some stuff that otherwise it's very unclear what your problems are.
Okay.
Yeah, and that's really, unfortunately, that's not everything. There's not like a single good answer on that, because I have definitely run a very weird gamut of issues like that, or like, so not even like just not working, but like, my junior game, to this day, some computers, so if you're in full screen and you set the, I made it so you can only just select low, medium, or high resolution because I didn't have time to create like drop-down mini UI. So that's what I did. And then internally, it does a method to figure out like what your best 3 resolutions in a certain aspect ratio are, and then if you're like in windowed, it drops the top one because otherwise if you clipped it was a weird thing. But it worked generally. But there are certain computers where for some reason, if you go to like medium or low, it will actually letterbox all the way. Like it will. So if you're like 1920 by 1080, but the resolution it gives you is 1024 by 768, it'll just be like this. Some it will be like full screen, and it will just be stretched, but which is what you expect. But some it will just literally give you 1024 horizontal pixels and 768, 1024 horizontal pixels, 768 vertical pixels, and it'll just put a black box around it. But that's like computer to computer. Now I don't know why. Like I could go back. I'm sure I could go back and track it down, but like at the time it was like, that's weird. And Ellinger was like, that's not good. And then like a week later I showed it to him on a different computer and we passed the TCR. But,
Passing is passing.
Hey, that's shipping on a PC, unfortunately, sometimes. There's just millions of possible configurations of hardware. It's impossible to target them all. When your teammates can't run your game, that's a problem. it's going to run slower, but in the very least, if you can run it through like a reference device, it'll do it in software. It will at least work. It may not run super fast. It may not be running at 60 frames a second, but it should always run unless you internally created bugs, and then that'll at least help you isolate that those are your bugs and not something else.
Okay. So kind of following on that idea of the reference device, do you have any other cool like tips or ideas or techniques that we might not know about that are really useful?
Yeah, I gotta think about this. So, it's a good question. Give me a sec to think about this. So, like in DirectX, the debug layer is amazingly useful. It will, but it's very noisy by default settings. Like it will suddenly, you'll go from like everything seems fine, you turn it on, and there are like hundreds of warnings, and not all of them will make sense. Like you will clean up everything, and it will still tell you that some of your state objects have outstanding references. Now, this might be better now. It's been a little while since I really had to dig into this myself, but you know, in like Visual Studio 2013 in DirectX 11.0, like I had issues with that where as I shut down, DirectX still had references that it cleaned up outside of main, but the debug layer still let me know there were outstanding references. And it's like, so the debug layer helped me clean up some places where I forgot to release references as I shut down, and that was good, but then there were always some where it was like, no, you still got one. And as far as I can tell, that's because the debug layer itself hooked like my device and reported a reference and then released it and exited. Because there were no leaks in the end. It was just, you still have a reference hook somewhere. And, if you're using the Visual Studio graphics debugger, it's not 100% clean about misreporting its own hooks, because essentially it has to hook your program to analyze it and give you information. But you know, those are hooks. It creates a reference to your device. So if you create your device, you got a reference count of 1. The graphics debugger hooks it, now you got a reference count of 2. When you release, it's back down to 1 if you release before the debugger does. Fraps does the same thing. Fraps does the same thing. My sophomore game, you had to make sure that you stopped frapsing before you hit the end of a level, because so these are things I probably shouldn't admit to, but what I ended up doing, because I put off handling, because my sophomore game was DirectX 9, and I was, I hadn't actually done graphics before then, so I was just learning, like I'm sure most people do, like who does actual graphics work freshman year. So, and I put off Lost Device for a really long time, so when I finally had to deal with it, I got it working, and then I had some stuff with like the loading screens between levels and the transitions, and so what I ended up doing is every time we had like a game state transition, I was just like, whatever, Lost Device, just reset it. It's fine. So like every time you ended a level, if you restarted a level, if you ended a level and went to a loading screen, or you went from loading screen into the next level, a Lost Device call happened, which was fine. Our loads were fast, and so the expectation was an extra couple of microseconds to just force it to do this Lost Device, just to handle a couple of odd edge cases I had encountered with like like locking the computer while the game's running and some other weird stuff. It generally worked, but what would happen is if you were frapsing, Fraps would put a reference into my device, and then I hit the end of the level and I would try to call Lost Device, but Fraps had a reference that I could not get it to release. So it got into an infinite loop on trying to handle Lost Device. But who other than me trying to get clips for my game trailer is really frapsing my sophomore game, so it wasn't that big a deal. But you hit weird stuff sometimes. But like being aware of that kind of stuff, and the fact that debuggers will give you that kind of stuff. So RenderDoc is another one of those. So all the various tools have their pluses and minuses. Like the Visual Studio Debugger is pretty good nowadays, but you have to be running at least Visual Studio 2013, and you probably want to be running 2015 to get the better version of it. But that requires you to be running DirectX at least version 11, at least be running Win 7. For 2015, you need to be running Win 10, right?
I think it works on Windows 8 as well.
Does it?
I don't know about the
does
graphics
the
debug.
graphics debug, because I think it hooks into the 12 SD? I'm not positive. Maybe it doesn't. But there are some limitations there. NVIDIA's Parallel Insight is a really great tool if you have an NVIDIA card. So all of them have pluses and minuses. All like there are aspects of how information is collected and laid out for you that I like about Visual Studio Graphics Debugger. There's some that I like about Parallel Insight. So RenderDoc is the third one, and the nice thing about it is that it doesn't care what kind of video card you have, and it doesn't require you to be using Visual Studio or be on any specific kind of Windows. I don't know if it. I've never tried to use it in OpenGL. Maybe it works. Maybe I don't remember. I feel like no. Maybe it does. Either way, but it is made by a guy at Crytek as their own profiling tool, and it does a lot of the same stuff, but it just has a different set of limitations. But one thing that it does have that's kind of nice if you choose to do it is you can actually code your engine to its API internally, so you can actually generate like you can instrument your engine for RenderDoc, which has the potential to allow you to target specific areas you want to look at, control the granularity. Because one of the things, especially if you're not familiar with it, you jump into something like Parallel Insight, like the Visual Studio Graphics Debugger, and there's just too much information. Like the first time you jump in, it's not going to help you. They're amazing tools, and once you know how to work with them, they will absolutely help you. But it's just kind of like, I'm going to click through everything. This is amazing. I don't know what to do with it. So the ability to instrument your engine to target how RenderDoc gives you information and where it gives you information, I think makes that really useful. So I recommend it if you have the time to invest to do it.
Okay. Cool. So moving into more graphics architecture stuff.
Sure.
What kind of things should the sophomores, because I see a good number of them in here, what should they be thinking about moving from like working strictly in 2D for Game 200 usually to 3D in their junior projects?
Sure. So, I mean, what, 2D to 3D, it's just like an extra axis, whatever. So I will say, one thing that I got told that I don't feel is very true is that it's a completely different ballgame. That what you write sophomore year has zero applicability. Like, the technologies you develop for your 2D game are absolutely worthless for your 3D game, and I don't think that that's true. Not necessarily, because I think a lot of the same concepts hold true. I mean, you want to be able to iterate through the things you're going to render, to group them for the fewest amount of state changes, essentially so that you can make the fewest draw calls with the fewest state changes and have the least amount of overdraw, because that is what's going to give you the best performance. Now, how you accomplish that in 2D versus 3D might be slightly different, but the general concepts of like gathering up like a render queue or whatever you want to call it, but like a queue of renderables, processing them into discrete batches. That's all applicable. Like, and I mean, it depends. Depending on the game you make sophomore year, depending on the game you make junior year, you're gonna have different tech requirements. Like maybe your game in sophomore year wasn't so complex that you needed to write any kind of batching system. I think you should always have a batching system. It's ridiculous if you don't have a batching system. But maybe you didn't. I know a lot of people my sophomore year that kind of sort of got away with not doing it. They also occasionally had weird hitches and they had performance problems. They were intermittent at least, so they, like I said, they got away with it. But I mean, anytime you want to build a good piece of tech, you need solid foundational code, and instancing is part of that. So the batching, instancing, whatever you want to call it, being able to group things with similar draw properties into a single bucket buffer and execute a single draw call on all of them is fundamental, regardless of if you're in 2D or 3D. So if you already built some kind of batching system for sprites in 2D, extending it into 3D is worthwhile. And if you didn't do that sophomore year, I highly recommend you looking into that, because that was actually a fun experience. So moving from 2D to 3D, and also from DirectX 9 to DirectX 11 going into junior year, reading through the documentation, one of the things is like, one of the things we did with DirectX 11 was we moved to eliminate a lot of the draw overhead, or a lot of the overhead involved in the actual draw API call. And whereas in DirectX 9, your performance was very directly tied to number of draw calls, and there were very specific, more or less, limits on if you want to hit this kind of frame rate with this card, you need to have this many draw calls or less, and that's not so true. And I mistakenly took that to mean I don't need to do any instancing. It's fine. Like, I'll just draw everything. And that's not true. That's not true at all. Don't make that mistake. Unless you're making a game where you need to draw like less than 1,000 things, you're probably fine in that case. But if you want to do more than that, and
Particles.
well, sure. Okay. And so, by the time I ended up having a big problem junior year with this, particle systems and my lighting all ran on instancing, but main geometry still didn't. And that was like one of the first things I fixed going into senior year, but I just didn't have time to fix it. But fixing up instancing for those two aspects at least brought perf in line. But don't make my mistake. The single best performance gain you can make is limiting the number of state changes, the number of draw calls. Find ways to gather things, figure out what you'll draw that frame, figure out what's going to actually be visible, figure out how you group them into like containers so that you can draw a large number of them on a single API command. Those are the things that will lead to high performance. Doing stuff like having an actual render thread is amazingly useful, but like detaching the render loop from your game loop, huge performance benefit. It takes a little bit of work, not as bad as you might believe, but it takes a little bit of work. Huge gains, but the risk to reward trade-off of just like setting up reasonable batching, setting up reference counting. Those things are really relatively easy, low impact, and will get huge gains. Because reference counting, I hope you guys are all reference counting your assets. Like, it's reasonable that many renderables will share a texture, and hopefully you do not have a copy of that texture in video memory for every single one. Hopefully you only did it once, and they all just keep a handle to it, and you reference count it. I just say, I say this feeling like I hope everybody's like, duh, because that's how fundamental it is. Because video memory is precious. One of the biggest performance bottlenecks is the time it takes to transfer information from the CPU to the GPU. And thrashing video memory is a very common occurrence, and it's the best way to completely tank your frame rate. So, MIPS. Is everybody using MIPS, I hope? Because I didn't junior year. No MIP chains. What are those? And if you don't know what a MIP chain is, do yourself a favor and look it up. Because the GPU's ability to optimally use video memory based on MIP decompression is amazing. Take advantage of it. It's basically automatic.
Okay, so on that topic of like data structures for rendering,
yeah.
One of the really cool ones is spatial data structures, and
Sure.
how you manage your scene. So what suggestions and tips do you
did that actually junior year. I built an tree to, well, I'm sure this isn't going to sound familiar to anybody, but junior year we're just like, we'll just make the biggest game possible, right? We were talking about making this open world game, and like I was developing tech in the renderer to handle like streaming content. Like it was this idea that like, interestingly, it was kind of like a Halo-like construct. But so wherever you are in the game world, you could look out and you could see everywhere else that you could possibly go. It wasn't like there were going to be discrete levels. You would just keep walking around, and you could always see everywhere else. And so everything kind of had to be loaded, but you had to. So, that's a great idea. I'm sure that would have been a really amazing game that we didn't make. So, part of the whole experience is that you'll start on an idea and you'll start developing tech, and then you'll throw it away. I threw away more tech than I shipped, for sure, and I'm sure that's a common experience. Help me out. I started down this train. What was the question that I was answering?
Spatial data structures.
Okay, right. So I knew it was too much data to reasonably handle, so I started out building an tree to try to do some spatial partitioning. It was going to be fundamental to how I streamed stuff in and out, because it was this whole idea that most stuff would never totally disappear. Like at a top level, you'd always have to see the basic structure out in the distance, and then as you got closer, you get more and more of the internal subdivisions, and those internal subdivisions would have like the various foliage and structures inside that block would hopefully not pop in, but they would be in a lower level in the tree, and then you get to a point where, but they'd be low poly, and then you get higher poly versions as you went down. We ended up not needing that because that is not the game we made, but I still had the tree, and you need a spatial partitioning system. Just like if you start to have any reasonable number of things that need to be rendered, if your game level is reasonably large and or dense, you're just going to have too many things. You need some way to, you can't just throw everything at the GPU and rely on its ability to be like, oh, well, while I'm transforming from object space into clip space, you're behind me, reject. Because again, some of the most precious resource you have is that you want to minimize CPU to GPU syncs. And so sending that data for the GPU to reject it is wasteful. You will need to reject it on the CPU. So you could go through every single object, depending on how many objects you have, that may not be a great idea. So a spatial partitioning system is good to kind of provide you an instant multi-level broad base, because anything, if you can reject some top-level construct, you instantly reject everything below it. So I ended up having reduced use out of the tree after we weren't making this amazing game that nobody was going to make in a year at school. But I still felt like it had some usefulness. But what I also found out is you need to be really smart, because on a very naive level, you're just implementing the tree and custom calling against it from the top down. That's cool, except what ends up happening is your level designers start by, all right, you're going to start here, and you're facing this direction. And I build the level out in front of you. How useful is the tree now? Because just like I was talking about with the platform, when it comes to like you're calling your spatial partition and all this stuff, you're only as good as your worst case performance, right? It doesn't matter if I start leveling and I turn around and I'm at 400 frames a second, but when I start leveling and I look out and I'm at like 2, like it doesn't matter that I turned around and I could project all the stuff behind me, great tech, but that's not helpful for the game. And so what I found was that, like from that basic approach, the tree seemed really good, and there were aspects that were going to be great, but it's like a lot of times when a level started, you were just looking out, and everything is within the visible frustum from where you started. So just spatial partitioning is great, and like physics, it's super useful. For graphics, it's super useful. Actually, for a number of things, and the way you implement it, it can be more or less useful. Make sure that it's actually being useful, because you're going to spend some CPU time to put stuff into those subdivisions. Do you have dynamic objects? You've got to handle what happens when I move out of one cell and into a different cell. And so what I found quickly in the early stages of this was, I'm actually spending a lot more time thrusting and calling against this huge recursive structure than I'm actually getting any benefit out of it, because my worst case is the second you start the level and the octree provides no benefit. So there's still things you can do to make it worthwhile, but it was like, the original version was, because originally I was just using the string stuff in and out, right? It didn't matter, everything is visible, but I still, stuff out that far was, because it actually had, it almost essentially had different level chunk files at each level of the octree that it would stream in and out. But then when I just thrust and called a basic level against it, that's not the case anymore. Everything lived in leaves, and it was just a matter of how quickly down each branch could I reject. So based on that, like, there's an obvious problem. I think that spatial partitioning is immensely useful. Your game here may or may not need it. It really depends on what you're trying to make. Any AAA level game developed today has to. There's just too many things. It's unreasonable to expect that you can just have a random, I'm going to call it object soup to kind of play off the idea of polygon soup, but right, it's unrealistic to expect you can just serialize in all the objects in your level and just every frame iterate every single one of them. You need some way to early reject things, and so a spatial partitioning system is a way to do that. But it's important to make sure that you pick the right spatial partitioning system for what you're trying to do, and to actually code into it things that make it useful. Because like in my case, initially, after we reworked our game, it was totally not useful. It was in there and it was actually de-optimizing our game experience. So it's a good thing to think about. It's one of those things, it's a good thing to think about while you're a student, but you may or may not actually need to develop that technology for your student game. Great, I mean, if you make like a small arena-based game that takes place in something that's like 50 by 50 world units, and there's maybe a maximum of 300 things in a level, it's actually somewhat reasonable that you can just iterate everything. Doesn't matter. And some people will make that game, and you just polish it up, and it's a great game experience. Some people will end up doing this thing where they have like 10 artists throwing content at your engine, and you end up with some crazy gigantic game, and nobody wanted it. You just need to be smart about what it is you're making and make sure it's doing for you what you think it's doing for you.
Okay, so that's interesting. Kind of depending on what the optimization is, you suggest doing it either earlier or later on in the project. Because like with batching and instancing, you said that you're pretty much always going to want that, so you would want that like early on. Whereas the spatial data structure, you kind of want to see where your game's going first.
Yeah. Well, and I mean, anything is refactorable, right? And I guess it will really depend on how your renderer is set up, but at least for me, based on what I did, it was much easier to go in and just change the data structure where I stored my objects, and then have that data structure have additional functionality internally, than it was to go in and change how my myriad of renderable types interacted with being told to draw themselves. And part of that was maybe some bad design on my part at the time, because looking back, it's like, well, I shouldn't have made these things draw themselves. I should have, maybe I should have been, hey, I want to draw you now. Things could have been flipped, but based on how my system was set up at the time, it was definitely a much harder refactor to try to shove instancing in than it was to try to shove spatial partitioning on the overall So I did. Number one, what's probably going to happen is you're going to start with that FBX exporter that's on Game Central. And step one, if you look at that code, it's going to make you believe that if somebody makes an animation in 3ds Max, somebody else makes a scale animation in Maya, and they both try to export it through your thing, it's going to handle it. It will not. That is not true. And I'm going to guess at the time it was made, this worked, but something happened, because when I tried to do that, that does not work. So I ended up having to make 2 versions, explicitly, because there's a part at the end where it will fix the coordinate system, because by default, Maya and Max have different handedness coordinate systems. And so in that FBX exporter, it tried to detect which program the FBX was exported out of, and then based on that, it applied a matrix multiplication to fix the orientation for the axis system. And I'm going to guess at some point, Autodesk's SDK actually allowed that detection to work, but it did not when I tried to use it. So number one, make sure that it is actually that it's exporting to the correct coordinate system, because it may secretly not be doing that. So scalable animation is fun, because the first thing you need to do is you need to figure out your organization of data. I split up the actual skeleton data from the animation track data from the mesh data itself, and I kept them separate because I wanted to be able to, if possible, plug and play, like just drop in different animation tracks or swap skeletons. That's not necessarily like out of the box easy, but it's much harder if your data is if all 3 things live together in a single file. So I did that. My junior year experience was fun in that all my artists were using Max. And Max is great from a programmer perspective. Max does what you expect. Max winds all the triangles the same way. So it maybe doesn't optimize the mesh as well as Maya does, but it has consistent triangle winding orientation, which means that if you allow the exporter to take the tangents and binormals as they're authored, or say, oops, artist forgot to export tangents and binormals, we'll just recalculate them. That makes sense in Max. It's super easy. Maya, just in an effort to optimize the mesh, it will wind each triangle individually, so some will be wound clockwise, some will be wound counterclockwise. Now, if you dig into it, there is a way to extract that information so that you can apply a negative scale to the binormal to fix it. But if you don't, what will happen is everything that you export out of Maya that tries to recalculate tangents and binormals will end up as a giant sea urchin, where every single point collapses into the middle, and it's just a bunch of spikes that go, here's a point, but the other end, like every triangle collapses into the transform. That was my experience. So what I ended up doing, because who has time to really invest too much, is I just said that if you export from Maya, you have to have tangents and binormals authored. If you don't, I rejected it, because I wasn't about to spend time trying to figure out how to properly recalculate each triangle individually. Max was great, like that worked. Maya didn't. So that was actually a big ordeal, because I had a number of issues, not just with scalable animation, with Maya in general in that regard, because what would happen was, so tangents and binormals being flipped in some cases meant that an artist creates like this wall, and bring it into the game engine, and it looks great except this one. So like this face looks great, this face looks great, this one, but I come on this side, and this triangle looks great, but this triangle is black, because the tangents and binormals are inverted, And so my lighting calculation is like in .L, shadow, and so the whole triangle turns black. And that didn't even have anything to do with skeletal animation. So skeletal animation only compounded the problem. I guess number one though is like you need to be very explicit. Like you need to make sure that your data actually makes sense. So in that case, like before I was validating that properly, I was just like, this is a mess. This doesn't look like anything. Like every single skeletal animation exported into the engine from Maya just was a mess. It's not even that it wasn't like animated correctly. It was literally one point from the triangle would be in the correct position, and the other two collapsed to the center. I couldn't figure it out, and that was legitimately just bad tangent binormals. When I changed the exporter to just force it to take the tangent binormals as they come from Maya, and then told my artists, make sure that you export those. That worked. That's great. So, but content, just the content in general is a huge problem. Figuring out how to make your because what will happen is you'll have one mesh, and you have one skeleton for that mesh, but you probably want to have multiple animation tracks. So figuring out how to make your exporter deal with multiple animation tracks, because and that's not even necessarily hard, but based on the sample code and information you're given, that's not a thing, right? That's not in there. And then how you organize that, and that's not that bad. So what becomes bad though is blending that data, because what you're gonna want to do is you're gonna want to have like an idle pose, you're gonna have like an idle cycle, you're gonna want to have like a walk cycle. You're gonna want to blend those together. So that actually becomes an interesting challenge, depending, and that can be really time consuming. And so if you're not familiar with the concept of a T-pose, you're going to want to get real familiar, because the way that all animation blending reasonably is going to work is like you don't want your animators to can each animation entirely by itself. Like you don't want to have like a run and a walk, and then a run and shoot, and a walk and shoot, and a shoot while idle, because those are not going to blend well. You're going to have troubles, you're going to have all kinds of weird pops, things aren't going to work right. What happens if you're walking and shooting as you turn? So you're going to end up needing to author animation tracks for running, for walking, for shooting, for turning, and what your system should be able to do is you can do additive blends for animations, but they need a consistent basis to add from, and so the T-pose provides that. That's relatively basic. Some of you guys might actually already know this information. So sorry if that's like something you already know, but it's important. It's important to have the T-pose and be able to use that as the basis for blending out other animations. There's actually a really interesting talk from GDC a couple years ago. I cannot remember. The game is called Overgrowth. It's about rabbits fighting each other, but like anthropomorphic. That sounds ridiculous. It's not that ridiculous. But he gives a really interesting talk about building a procedurally blendable animation system. If you're interested in animation, if you're interested in being able to have like a wide range of animatable movement that feels and looks good, I do highly recommend watching that presentation, because like he really, in the presentation, he actually shows in his engine step by step. He's like, here's what happens if my character is just a capsule and it just slides across the ground. And it's like, well, nobody wants that. He's like, so I'm going to put a walk cycle, but it's like it doesn't fit to the ground. So he's like, so then I'll use inverse kinematics, and now as he steps into the ground, it reacts to that, but there's no transition from like stop to as I build up to a run, and so I can do that, but then like actually like authoring an algorithm to create kind of a spring weight to actually create like a softmax taper. Like it's a really interesting talk. If you're interested in animation system, actually building like a legit deep animation system, I do recommend that talk.
Okay, and then you mentioned the loader on Game Central.
Yeah.
So the other part of that is that it has a binary format it generates. So I know the reasoning behind that is that loading like an FBX is usually So do you have any tips on that?
Yeah. Well, so no game engine consumes no professional game engine consumes an FBX directly or a Maya file directly. No professional game engine consumes like PNGs or TIFFs directly. Most content types get processed because the fact is that like a TIFF is a great format for an image, but it's also a format designed for a wide range of uses so that it shows up in Photoshop, so that your camera can take a picture and store it in that format, so that I can put it on my television, I can watch it on my computer, we use it in game, but like there's a lot of uses. It's kind of like the argument that people make against the STL, right? The STL is great in that, do I need a container for unique objects that I can iterate front to back? Oh, the STL's got you covered, you're done. But is that going to be the most performant solution for you? Probably not. It's the same idea with just about any kind of content. You could consume the content as in the format it's authored, but there's probably a lot of extraneous information that you don't need. And if you can, it may be fine. Like for your game, with any piece of advice, what you're going to want to do is get it to work. Step one, functionality. Just get things working. Once things work, if you have performance problems, you investigate where your performance problems are, profile, you get data, and then you actually fix it, because it's really easy to fix the wrong problems. Like, yeah, are you going to have more optimal experience having your game engine at runtime consume a custom binary format for your meshes as opposed to the FBX directly? Absolutely. But if, like if you don't have instancing, and so you're trying to draw 10,000 renderables with individual draw calls, your performance problem is not consuming the format for your meshes that you're trying to consume. But it's still probably a worthwhile place to invest in. The fact is that, so I do recommend it, but at the same time, having the exporter stripped to FBX, even just using a super basic readable ASCII format that just has a minimum of the data. Because the FBX stores all kinds of stuff. Because it will store information about the vertices and the vertex and index lists, but it'll also keep like transformation hierarchies. It'll keep potentially information about cameras in the scene, lights in the scene, depending on the program that authored it. A lot of stuff that you don't need. Even if there aren't any, it'll still have tags that have no data in them, but those have to be parsed. So at the very least, just writing something that takes the FBX and only takes the barest, smallest subset of information that your engine needs, and then just writes it out into like a text file, that is still going to be a pretty big improvement over trying to consume the FBX directly at runtime. Yeah, any piece of content, it's going to be great to have a really streamlined, the highly compact binary format, but in the case of content, a lot of times it's just step one after it's functional is just being able to strip out all that extraneous information that's there on the generic level, so that these myriad of different programs and uses can interact with it. Getting rid of those and targeting just the data set that you need is a huge benefit in and of itself. At school, I did not have, most of my stuff didn't deal with binary format. I didn't consume any of the resources directly in their original authored format, but I at least wrote something to convert it into like a text file. And then, because, time difficulties, I didn't always have time to build very robust validation for some things. So having a lot of things in text format made it a lot easier to be like, something didn't load right, let's just open up the file and make sure there's nothing weird, because once you're binary, you can't do that. It all looks weird, right? So if you're going to go to binary, not only do you have to figure out that format and how you're going to do that conversion in the format, you need to also make sure that you have some kind of tool that if something goes wrong, you haven't lost everything, right? Because how terrible would that be? You have some level file, and of course I guess it's hopefully under version control, but if you have some file and it's got thousands of objects in it, and some dude's been working on it for weeks, and now suddenly it won't load. That's a problem. That's a huge problem. Like losing weeks of work and having no recovery mechanic at all. Nobody's going to be happy. You don't want to put yourself in that position. But it takes a lot of extra time to build every piece of machinery that's necessary to make that happen. So, step one, just always make it work. You can always fix performance later, usually. But you generally can always fix performance later, but it's very easy to put yourself down a very weirdly narrow path because you built the wrong kind of optimization in early, and now again, everything is solvable through a refactor if you want to put in enough time and effort. But you'll put yourself down a path where the time and effort to fix it is not worth it, so you need to scrap it or live with the weird decision you've made. So yeah, usually step one, just make it work. And it's going to be bad, people will be annoyed, but at least it will be functional. Once it's functional, people can live with it, and then you can hopefully start a quick turnaround to at least get it to more acceptable performance, and then later down the road you can really dive in and tweak it. But I'm certainly guilty. It's really easy to get down that rabbit hole of it's really slow, go through, fix it up. All right, now we're running a good frame rate, everything's fine, but I could do something more. And you get in there and you're fixing something, and you're just making micro tweaks, and you're I can squeeze another 600 microseconds out of this. And it's yeah, you can, but is that the problem with your engine? And you get it, you get super tunnel vision, and you're just you're fixing it, and it's oh, that worked, yeah, let's do more. And you just keep focusing more and more in, and I'm super guilty of that. But there comes a point where you need to make sure that your teammates aren't why aren't you doing this thing that's not important anymore? Be aware of that. Don't not create important necessary features that are blocking the work of your teammates, so that you can try to do something really cool to squeeze out this much extra perf. Super common to trap to fall into. And again, I'm super guilty of it, but I don't know. I feel like that's a pretty good piece of advice to try your best to avoid, but you're going to do it.
I'm guilty of it too.
Yeah.
So on the topic of loading assets, another cool feature is being able to hot load assets while the game is running, so
Sure.
you don't have to do a full restart of your game. That's really useful for iteration time. So how does that kind of change going into graphics, specifically with textures, models, even animations, and especially with custom binary formats?
Sure. Well, I don't know that it needs to change that much. It depends. Certain aspects will need special handling. I don't think it's really too much of a specification in general, though. The biggest thing is that when you hit the point where you're starting to build job systems and you're starting to thread things out, it doesn't matter if you're in graphics or somewhere else. Then you need to be careful that your hot reloading doesn't enter you into weird deadlocks and race conditions. And so I guess for graphics, there are some cases where you need to make sure that you hot reload in a safe way, that your device is not currently consuming the resource while you try to do that, because it may not crash you, but you may get very odd results. There are ways to handle that, but everything is generally hot reloadable, and it's a good piece of advice. I would though say that you may want to wrap your hot reloadability inside a macro, because you do not probably want to ship your game able to hot reload assets. Well, number one, it's probably not that useful to your players anyway. But number two, if a player somehow figured out that your engine can do that and what your format is, and tried to inject weird content of their own, maybe you want to actually prevent that. because I mean, a basic hot reload scheme does something along the lines of, for each piece of content, it puts like a file change timestamp watcher. Like you occasionally query the most recent time change, maybe you hash that and compare it against the last hash you have, and if it's different, then you know it changed, and then you need to reload the asset. And so that's all really basic, and that's easy to do. But wrapping the asset load inside of a macro that, in a build where you want that to happen, does that, and otherwise results in a no-op, makes your life really easy. Because what's going to happen if you don't do that is you're going to write this really awesome code that does this, and it makes your iteration really easy. And then it's going to come time to package up your game, put it in an installer, and get it on the game gallery, and you're going to realize, oh, that still happens. And, I mean, since we're just talking about micro optimization, the fact is that at runtime, when you don't want or care about users like hot reloading assets, that, you know, occasionally querying the last change timestamp, hashing that, comparing that hash, those are cycles. Not necessarily like a huge number of cycles, but those are cycles. And we're in, you know, a space where every cycle counts. You don't want to leave performance on the table, and especially performance that was easily acquirable. And that's one of those places where it's easily acquirable. There's a lot of stuff that you're going to want in an internal build, maybe not even just a debug build, but like in an internal iteration build that you want to have turned off when you go to ship the game. Or you want to go to playtest, and you know you want some features on, you want some features off. Like this is actually a huge topic about how you want to be able to have you want to have calls wrapped in macros in a way that you can turn those features on and off, so that for a build you're only paying the costs for what you need. Like you go to playtest club, I don't need debug iterators. I don't need the debug heap. I don't need a large number of things, but I want enough symbol information that if the game crashes, my watchdog thread can pick up that crash dump and, well, okay, so senior year, I built a system so that when the game crashed, I get a crash dump, and I built a launcher. So this was the easy way, because you know ideally what you think is like in a debug build, you want to actually have some the main thread actually some kind of like debug watchdog thread that monitors the health of the game thread, and so if something goes wrong, that watchdog thread realizes something went wrong. It can collect information, it can generate a crash dump, and then it can give you all the information you might need to be able to know what went wrong, track down the actual problem, and fix it. That's a lot of work. That's potentially a lot of work, and depending on where you're at with your architecture and what's going on, that might be really invasive to try to get in after things are already running. So what I did is I went to C# and I built a small graphical launcher, and what you can do is, so when you hit play, it would just do a fork and exec on our game executable. And what you can do with .NET is that you can hook an event watcher to the on-close for that. So I set up shared memory between the game and the launcher. The launcher just went invisible, but it acted as a watchdog thread. And so if the game ever exited with a bad exit code, it would trigger the event listener in my launcher that would collect whatever information the game was able to put into shared memory before it completely crapped out. It was able to get the crash dump, and then it packaged it all up, and then made an SQL query to our bug tracker and filed the bug with attached crash dump, which is amazing. That part of that though, like for crash dumps to work, you actually have to have binary builds that you keep track of, and you have to match your crash dump to your binary build, otherwise your symbols don't match. And so if you've ever taken CS391, I highly recommend it. What? Okay, maybe I don't recommend it, I don't know. It was amazingly useful when I took it, because one of the things it got into was that kind of stuff. Not at that level, but just the idea of generating crash dumps, using the crash dumps against the known binary build for your executable that crash dump was generated against, and using it to actually track down through the disassembly where your crash was, makes it so much easier to identify and fix problems. And so, but that's one of those things where, actually in that case, ideally, if we had finished that game and shipped it, that is not a thing that happened because senior year. Out in the wild, that actually would be useful. If somebody's playing my game and it crashes, a prompt comes up and says, hey, the game crashed, could you fill out a little information about what happened? They fill out some fields, they hit send. I generate an SQL query that takes that information, plus my crash dump and whatever other internal information the launcher generates based on my code, and then files a bug with me. And then I have the ability, potentially, to fix that bug and release a patch. Now that's not realistic for a game I made here at school and it's on the game gallery, but that's like how real games work, right? I mean, you need to generate user data, and that's the only way you're going to get it. When a game crashes, the user needs to be able to tell you about what happened, and you need to get crash information from them. But, like internally, when we're sitting in our team space, I generated full crash dumps, and a full crash dump was like 600 megs, and that's fine. We're on, like our build server was local network, and no user, whether they know it or not, wants to generate and then send a 600 meg crash dump. Now that'd be nice, but the fact is that, so for our internal iteration builds, I had full information in the crash dump. For the release builds, I had settings for the crash dump generation that were slimmed down that still gave me enough simple information that I could identify problems if I ever got tickets filed from users, but that were more on the order of a 30 meg crash dump. And that kind of stuff. And so wrapping that stuff in macros made it very easy, where just there's a file somewhere inside the engine that just had like a pound if, pound else if, elif, and inside of it, it was like, well, if it's this build, I set these flags this way. If it's this build, I set these flags this way. And then when we changed configurations, it just changed everything. And so there are a lot of cool debugging features that you will want to track for yourself, like asserts, like profiling stuff, like tech that powers hot reloading. This was a really long answer to the question, but it's kind of a more general topic. And that stuff is amazingly useful, and you'll want that, but you probably don't want to ship a lot of that. But also, like, if you're trying to get a realistic and accurate profile of your game, you need instrumented. So I guess if you use an instrumented profiler, but you probably want to use an instrumented profiling system. You want the macros for the instrumentation to still be active, but like profiling the fact that you're checking and trying to handle hot swapping content or various other debug activities skews the results of your profiling data, because that's not really realistic to the game you're going to ship. And so just being able to have a list of configurations and having those tied to settings that automatically change what the nature of what your code does is incredibly useful. You need to be careful because it's very easy to obfuscate your code to a point where it's really impossible to understand what a line of code does. And that's the other extreme. You don't want to do that. But just in general, like hot reloading is a really good example. It's the kind of thing that you want. And it's a really simple system. Like honestly, it's as simple as like if you're on Windows, you can use the Windows API to query the timestamp for the, like when you look in like Explorer and it tells you last changed, Windows API provides a really easy way to get that information. And so you can, on a periodic schedule for each piece of content, have your engine query that timestamp and compare and store it. And then the next time it queries it, compare it to what's stored. And if it changed, your file changed, you need to reload it. That seems like a really easy piece of tech to write, right? And that's amazingly useful because, I mean, think about right now, how long does it take So load up Visual Studio, hit F5. How long until you're actually playing your game?
Too long.
Right. So the idea of being able to have an artist, they probably won't hit F5, you'll give them an executable, have them start the game, and while they're playing, being able to like go into Photoshop and make a change to a texture and save it, and then see that change in the game, that's incredibly useful for iteration speed. That's fundamental. But then it goes to the point where, so if your engine consumes a different format than the authoring format, you also need to handle that. And then the question becomes, in like iteration mode, do you set up two paths for content consumption? One that like in iteration mode just consumes the content the way it's authored, and then like you package it up and consume it in your like super tight binary format for shipping, and that's viable. That's something like, think about Unreal. I mean, there's a very long process if you actually want to tell it that you're going to build your assets, like your game for shipping, see in like 2 hours, because it takes a really long time and it bakes down all your assets. There's some other things, but you know, your ability to just be like, boom, I want this texture on this thing, and it just does it. But that whole engine is set up so there's almost two engines in one. One for what your actual shipping runtime game will more or less be, and then one for creating and editing the game. But, you know, and that's actually a really decent experience. Talk to somebody that's used Unreal, and I feel like nowadays it's a really great experience. But think about the additional dev time needed to essentially create two engines to be one engine. But then if you don't do that, you gotta think, well, so now I gotta have a file watcher that realizes that my TIFF changed so that I can have my converter turn that TIFF into like a DDS. But then I also need to have a second file watcher that knows that the DDS got modified so that my engine reloads it. And it's like, that's not like the worst thing, but like, where does that stop? There are possibly more than two links in the chain depending on the piece of content we're talking about. So it's incredibly useful. You want to do it. You absolutely want to do it. You can hot reload shaders, right? But then you need what you need to think about though is that you need to detect changes in individual fragments, and then you need to reconstruct the whole programs based on changes to the fragments, and then you potentially also need to safeguard against trying to update the contents of a fragment while that frame is drawing. Like in most cases, I think the APIs are more or less safe as far as changing the CPU resource while the GPU is running because it's already been transferred to the GPU. But that's a thing that you might want to be aware of because in some cases it's possible to try to change a resource. And especially I think with DirectX 12 and Vulkan where you have a much thinner API layer and you're touching things more directly, it's way more possible if you don't guard against these kind of things to touch a piece of content while it's in use and destroy everything. So from that standpoint, I think going forward, and that's the thing with graphics APIs in general. Over time, as the APIs mature, we get more power and more control, but we have to write a lot more code and we have to guard against a lot more things. The APIs become thinner, and the thinner layer of abstraction inherently means more performance, but it also means that we have to handle a lot more stuff ourselves. And so in that case, it's like you will actually, so like in DirectX 11, if you wanted to set up like a basic deferred context system, that was actually really easy because you're like, I make a command buffer and a deferred context, I pair them up, I send them to a thread, do some work. When you're done, I get the command buffer back, and I just tell the immediate context to execute it. And all of the virtual memory remappings that happened behind the scenes to make sure that all the data in flight was always valid and safe so that you could send that out to that thread and then it comes back and the command buffer contents are in the order you expected and they're all safe and now you can touch them. DirectX 11 handled all that for you. That was a black box. In 12, you have to write all that code yourself. But you can get exponentially more performance from the deferred context system as a result. But it goes to the same kind of thing with like file formats like the STL, the less work you have to do, and the more generally something functions, the less optimally it functions for a use case, right? And so that's kind of the thing. And so as you go into more modern and more advanced APIs, I think you're going to find you have to do a little bit more safeguarding to make sure that the resource that you're hotly loading is not currently active, and then you're not like corrupting GPU memory while you do it. But otherwise, it should be no different than any other kind of resource hot loading. I mean, you just need to detect the change, reload the resource, and make sure that propagates outward. It's a really long answer with a number of tangents, but
yeah, it's good information.
But I feel like that's useful, and that's honestly just the idea of wrapping certain things in macros so that I can control the functionality or just disable functionality between different build types was something that I really didn't do in earnest until senior year, really. Like junior year, I did very little of that even. And thinking back, that's ridiculous. I mean, just the basic concept of an assert, like your code should be littered with asserts. But hopefully your release build does not have any. But that should tell you about the status of the code base for my junior game. We basically didn't assert check anything, which is crazy. Like thinking back, that's crazy. Like I don't even understand how we functioned.
On the other end of the spectrum, though, don't go too overboard on macros.
Yeah.
They can make the code base a little bit harder to read and harder to work with. I'm guilty of that one.
Yeah, well, it is a balancing act, but like you can get to the point where like an entire file is just wrapped in a macro, and then you go to the file where the macro is defined, and it's like actually that macro is generated from the macro. Like, yeah, it's easy to get ridiculous, and at some point somebody had a super good intention, and I'm sure it made sense. But over time, it just gets mangled into something really gross. But the basic idea that like you would wanna have a macro so that you can place assert, so you can place profiling instrumentation throughout your code that in certain builds does that thing, and in other builds just results in a no-op. Like at a super basic level, that's the kind of thing that you should be doing. Hopefully you're doing it, because that will make your engine a lot easier to manage. Yeah.
Okay, and then another big, also off topic, but I remember a little while ago, before this question, you mentioned the STL isn't always the best option for what you need. Actually, just today, the full EA STL went open source. So that's actually an implementation of the containers and algorithms in the STL, specifically for games, written by EA. So that might be a good thing to look at. It gives you a lot finer control over memory and allocations and such.
And you know, they're not the only ones. I cannot specifically remember, but sometimes it's super useful to actually pay attention to the credits in games, because I want to say, like, I want to say it was like Deus Ex, Human Revolution, like, you know, they use some open source modified STL library, but like, they have to attribute that. So like, you know, a lot of AAA games use a lot of various middlewares, and it's not always apparent what those are, but like, and some of them are as basic as like a container library, right? So like EA's STL, right? But like, and there are others out there, and those will actually be listed a lot of times in credits for games, because they have to. Like, did they use Flash? That's in the, you know, they have to attribute that. Like, so that can actually be a really good resource, because the fact is, if you need a container that does a specific thing and you just need it to work, the STL's got you covered. So you can get step one, get it functional, right? But you're probably at some point going to hit a point where you're like, my bottleneck is this container, and it can be a lot of work to write actual high performance and functional container from scratch. So having access to that kind of stuff is actually incredibly useful. I do highly recommend it. But I guess my point is EA's is not the only one, so you may want to sample the breadth potentially. And you can also potentially pick and choose. EA might have a really awesome like queue, somebody else might have a really awesome stack. I don't know.
Yeah, or even depending on what you're using it for, you can use both for different tasks within the same engine. So another big thing in 3D is lighting.
Yeah.
So you know, the hot new things are deferred in PBR. So what can you tell us on that front?
Well, I wouldn't even say deferred. deferred is a hot new thing. Deferred is a choice. It depends on what you want to accomplish. PBR is one of those things where PBR is simultaneously everything and meaningless. Right, PBR just means physically based rendering, right? But what does that mean? Because even when any game uses like a PBR based BRDF, it's still hacks on hacks, right? Like it's all tricks. We're not simulating photons with bounces, like we're not simulating a wave and a particle, like that's, so it's none of it is physically accurate.
Yeah, that reminds me of a Chris Peters slide from one of his lectures. It's just giant bold print, fake everything, and then a bunch of exclamation marks.
Yeah, no, that's pretty much, so the concept of PBR, it's really easy to throw around. But the basis for modern PBR kind of encompasses two main points. Number one is energy conservation, and number two is surface scattering. They kind of go hand in hand. But I mean, the idea is that before our modern concept of PBR, artists would author like a diffuse map and like a normal map, and they would author like a specular map. But what happens if you make your diffuse map and your specular map both pure white? Well, technically, you now have 200% energy, right? And that's the idea behind energy conservation in PBR. If you have a purely diffuse surface, that means that it's purely non-specular. 100% color value in diffuse has to mean 0% color value in specular, and vice versa. So it's balancing. I mean, that's a really, really basic level, right? Because there's a lot more that goes into the light calculations that determines this stuff. But at the end of the day, to be physically accurate as we best approximate it today, it comes down to balancing diffuse and specular energy, which is tough for artists to wrap their head around because they're used to just being like, I author this texture however I want, and I author this texture however I want, and now I don't actually have this texture anymore, right? I don't have my specular texture, I can't just author it. The specular becomes a result of what you author as like gloss and metallic, non-metal IOR, cavity, whatever properties you allow to be authorable in your materials, when they run through your lighting model, determine specularity, that that result, of course, gets balanced against the base diffuse to make sure that it's energy conserving. So it's one of those things where so when it works well, it actually has really good results, but it also can be hard for artists because the way that they control specular is through controlling like 10 properties that indirectly together create a result. But for like the last 20 years, I mean, at least right now the artists that you're working with, not the last 20 years, but artists in general, like the last 20 years, they authored a texture, and directly that was the result. And that is not how it works anymore. And so there are a lot of engines that get PBR right, but that don't. But then you look at them and you're like, well, this one looks this way and this one looks this way. And sometimes that can come down. Well, sometimes that is the result of how properly written, like the renderer is, the shaders for it. Some of it comes down to how well the artists understood and embraced how you work with that system. It's a complete shift in thinking for how that works. But in a way, it's what we're going forward. But at the same time, not every game is physically based, right? Like, if you're making a game that's supposed to be all cell shaded and stuff, PBR may have less value to you. But at the same time, it's not impossible to have an energy conserving concept applied to a non-realistic style. At the end of the day, though, the real idea is that, like, the guys that worked on Far Cry 3 gave a really interesting talk. It actually had to do with color calibration for the materials. Like, they actually they went around the world and took reference photographs of things with a Macbeth color checker in the image. So what they could do is for every single image, the color checker provided a reference point. So all these pictures were used to reprocess, so the artist would create like a diffuse texture. And what they found is that out of context, it's really common for an artist to over or under saturate the colors in the diffuse texture. And then when you look at it in the final composite, it makes it not sit well in the environment, and that even though you have an amazing renderer with a great, like the perfect PBR material system, your stuff still doesn't look right. And it's because the artist is just like, I feel like he's just in Photoshop making a texture. He's like, I feel like a brick wall should look like this. And that looks right to him at that moment, out of the context of the game. And then you get it in the game, and it's like, oh, that's not right at all. But being able to gauge that is really hard. So they created a system so that based on real world photographs with a reference in there, their processing pipeline was able to recalibrate artist diffuse textures based on those actual reference photographs they've taken. But it goes into, right, so that's crazy, right?
Yeah, tech we won't have in game projects for 500 Alex.
That is not stuff you'll make here. But it's one of those things where even if you're not going for a realistic look, the idea that you generate materials that fit your look, but also that feel like they properly sit in the world all the time is important. Because that's the thing, your material should be set up in a way where if you change the lighting environment around it, it always looks right in that lighting environment. And part of that, PBR helps ground your materials when done right. Helps ground your materials so that they do look right all the time amongst each other within a variety of lighting environments. And then, like our game, we have a number of materials that are supposed to represent real world materials, but like the Covenant don't exist, so Covenant metals are not real things. But they still follow our basic PBR system because those non-existent things, we still have to make them feel like they fit inside the same environment that things that you do have a reference point for fit. So like you still will create otherworldly materials that they still have to potentially feel like they fit in the environment. And it's just a goal to mathematically make sure that everything makes sense. So deferred, that's interesting because deferred is not necessarily even that new at this point, but it's a style. It kind of comes down to what you want to do and how you want to do it, and the distinction is blurring more and more all the time. Because early days you just had your basic forward. Your problem, of course, is that per fragment you have to deal with like number of fragments times number of lights, and that quickly explodes. And so then you end up with early on what that led to is a system where you're like, well, let's pick the 4 closest lights or the 8 closest lights or whatever we think the hardware can handle. And so that meant that your lighting artists had to work within the confines to know that like, well, if I put 5 lights way too close, I potentially have a pop through things because at this point it might pick these 4, but then at this point it might pick these 4, and so it's going to change which one gets picked. And so then that means that your lighting gets sparser so that you work with the constraints of your system and you still end up making it look good, but it ties your hands. You can't necessarily do what you want to do. And so deferred was this, the concept of deferred comes along and it's like, well, it's great, because now I'm not like fragments times lights, it's plus, right? Because essentially you draw your lights as objects into a buffer. So it really becomes additive rather than multiplicative. And so you go from, of course, so here's the thing. With forward though, you're evaluating the BRDF as you're drawing the final pixel, well, minus any post-processing. So you have a lot of potential material expression flexibility. Deferred, you draw all your lights into a buffer, and then you use that buffer as the final evaluation of lighting. And so in a traditional strict deferred system, all your lights have to follow the same BRDF. You can't mix and match. And then depending on how fat you want your G buffer to be, that limits how many properties that you can store between, which limits the flexibility of materials afterwards. But there are plenty of games that chip deferred and have shown that if you're smart about it, your artists can give the impression of a wide range of material variety when you really actually have a very limited set of parameters controlling it. But that's kind of the trade-off. It's like, so do I want to have like kind of unlimited lighting, or do I want to have unlimited material flexibility? Well, and then the other thing with deferred is you kind of had this thing where it's like, well, it also depends on kind of like, you could have different variants of forward lighting that picked X number of lights. Deferred had to pick X number of layers in the G buffer. And it was kind of like, well, if you got this amazing video card, well, technically, like, your APIs will allow you to have 8 targets in a rendered target. I don't think I've ever heard of a game shipping an 8-target G buffer. I don't think that's a thing. I would love to be corrected if I'm wrong, but I'm pretty sure that's not a thing. But a lot of engines, like modern deferred engines, will do like a 4 target G buffer. But like the 360, for example, could handle multi-target rendered targets, but only 2. So if you wanted to, so like let's say you're correct, and you make a game for PC. Did they do that? I don't know. Not important. Yeah, they did, right? And so you're like, our game's gonna look amazing on PC, and it's gonna do like a really fat G buffer. We're gonna use 4 targets. We're gonna be able to store all this data. That's 16 channels of data, however they want to organize that. That's relatively a lot of flexibility. But also, we need to ship our game on the 360, and the 360 is limited to 2 targets. So what do? Well, so they figure out something, but you can do something there, but you just have to find a way to either compact your data or shed a couple of parameters. And the other thing is that in a deferred system, because you've already, so you go through and you render all your lights, and now they're in a single screen space buffer. And now use that buffer to go through all your geometry and render them applying the lights. Traditionally, that has made it very hard to apply anti-aliasing because, well, it's very hard to apply anti-aliasing unless you set up your multi-target G buffer to be a multi-sample target. But that, so if it's like, if you try to use 4-time MSAA, your 4-target fat G buffer is really 16, right? Because each one of those targets in your 4-target G buffer actually has 4 targets, so that it can have 4 times multi-sampling that can be resolved down into a single one to anti-alias. Nobody is doing that. Nobody can afford that. So it's like, oh, well, you could actually easily anti-alias, easily anti-alias a deferred system as long as your G buffer is 1 texture. And maybe you do that, but I don't think anybody really ever does that. And then, of course, the other problem is that you've got aliasing issues at the light stage and at the final render stage, because there's geometric aliasing and then there's rasterization aliasing, and you need to combat both. And so by separating the lighting and the final material like that, you kind of potentially compound aliasing. So that's kind of been a thorn in the side of deferred renderers for a long time. It's just, it's harder to get anti-aliasing and transparencies, right? Transparencies are traditionally not unsolvable, but difficult problem for deferred renderers. Not so much for renderers. So then you start to see weird hybrid approaches. Like you've got light prepass or hybrid deferred. It's got a number of names. My system, junior and senior year, was this system. It's what Destiny uses, more or less. And the idea is that it is deferred lighting forward shaping. So you will draw your lights as objects into a light buffer. So you have to go through your geometry to build a G buffer, but it'll usually be a pretty thin G buffer. You then use that build your light buffer, but then after you have your light buffer, you do a forward pass through all your geo to apply it. So you do 2 passes through geo, which is a little expensive. It depends. There are ways that you can minimize that. What it lets you do is it lets you get the flexibility of having a lot of lights, like you do a traditional deferred, but then you also get the flexibility of applying material attributes on each object individually because you're doing that forward. It does still limit you to a single VRDF for the lighting, but again, it's kind of this thing where it's very hard to mix and match VRDFs and have a consistent look, so you don't see a lot of games do that anymore, so that's not as much of a concern. And then the other thing that engines are starting to do is now that compute is becoming more mainstream and usable, and the tools to debug it and to use it and the hardware support for it is more widespread, and you're seeing a lot more use, and it's opening up a lot of possibilities. And so one of those possibilities is what's known as tiled forward rendering. And what happens is, because it uses the same idea that original forward rendering did, where it's like, let's pick the closest 4 lights or closest 8 lights. But rather than doing that per fragment, or rather per object, and then every fragment that object renders with has those lights, what it will do is it will split the screen into equal-sized tiles, and then it will execute the compute shader per tile. It will bin lights per tile, and then use those the bucketed light information per tile to apply lighting to the objects. So you still do everything in forward, but you pre-compute in compute shaders lighting per tile, which means that essentially you get better light distribution. You still have limits, but do you have questions?
No, yeah, about that. Or do they essentially just batch, like once they provide all the tiles, just batch and it's all resolved parallel on the compute shader? Like, so I mean,
yeah, that's more or less that's the idea behind compute. I mean, so if you think about it, I mean, the GPU is a highly parallel machine. When you write a pixel shader, the idea is that it could execute on every single pixel on the screen. And so, depending on your card, it will execute something like a 64 by 64 pixel block simultaneously, right? So, but you're still limited because the way the hardware and the API has been set up, what the pixel shader does is very specified. So compute, the idea was that it's more general. It's kind of, it's structured to be more along the lines of being able to write like a C99 style program with that kind of syntax. But it's the idea of general purpose GPU programming. And so, yeah, so in this case, it's essentially you send in the light data, and then the tiles run in individual compute threads, and then you accumulate lighting data not per object, but per tile. And so for like a really big object, that, like, let's say you have the floor, and let's say the floor was one piece. That's ridiculous. Why would you do that? Let's say you did. Traditional forward, that whole giant single floor piece would just get the 4 closest lights to it, however pick that. Every single point along that floor would be using the same 4 lights. In like a tile forward system, in screen space, each tile would apply its lighting. So at different points along that floor piece, it's actually getting different light contributions. You still have a limitation for number of lights per tile, but because you've shifted how you attribute the lights over the objects, and you're seeing you get the better width of coverage for your lighting. And by powering it through compute, it makes the performance viable. So like trying to do that before compute shaders was a non-starter. But so with the rise of compute, that's why that's been a thing. But you know, it's not as big a performance optimization as it is for forward, but there are also engines that do a tiled deferred rendering. Unreal, I'm pretty sure, is actually tiled deferred. So it benefits, just not as much from splitting the screen up into tiles and then using that for lighting accumulation. But then it still does that in a deferred system setup. So but you're seeing a lot more hybrid setups. I think one of the things Destiny did, like if you go back and read their GDC talks, like they used one of the channels in their Gbuffer to store a material ID, and then they have like a lookup table that they put on the GPU. And so as they build the Gbuffer, each object into the Gbuffer renders an ID that represents its material. And so then when it goes to use that build the lighting data, it can actually have much more expressiveness of material because they just have a table, and that table can have here for these parameters, here are the values. And so that was how they got around having a more deferred setup, but keeping a fuller flexibility. Seemingly, like some of the details are a little obscured, but based on the presentation, that was their approach. So there are a number. If you want to invest time, there are a number of odd hybrids that you can look at. People are developing all kinds of weird approaches. Like, those are the traditional. You get your forward, you get your deferred, but that's not the end all be all, for sure. And it's interesting because, like a couple years ago, at GDC, you go to talks that like Epic gives, that Crytek gives, like all these guys making these Frostbite, all these guys making the big deal commercial engines in the industry, and all of them were like, forward tiled is the future, but the engine we just built is deferred, or like hybrid deferred, right? So it just depends. Like, and as hardware changes, you'll see shifts in what people think, where the trade-offs end up lying. Because I mean, if you look at like various games, various commercial engines, AAA or indie, the engines will run a gamut at any given time. But you'll see like at any given time, you will still see like a real build up at like this last generation, like a lot of these engines ended up being some kind of like hybrid deferred system, because the state of research and where the hardware was and what the trade-offs were. But a lot of them were also coming from deferred setups, so they started to sort of kind of embrace what they wanted to head towards, but it was an easier jump to kind of do it halfway. Any of them could be valid, though. It kind of ends up being, what do you want? Like, if you don't need a wide variety of material expressiveness, like if you're not making a photorealistic game, if you're just going to cel shade stuff, but you want like a ton of lights, deferred is perfect, because that deferred excels at a ton of lights. And so if you don't need if you don't need to be able to express the difference between like this plastic and this plastic, then you might probably be okay with deferred. You're just like plastic. But if you want to be able to have that subtle difference of these are different kinds of plastics, like the fibers of my pants versus the fibers of my shirts versus the fibers in this carpet are different, you may find that the limitations of how much data and how you can store it into a traditional Gbuffer setup make a deferred setup limited for what you want to do. It just, at this point, like when deferred first came up, it was basically like, oh man, that's so much better. Everybody do this now. But it's really not at that point anymore. Now it's like the various ways that the lighting technology have gone, they're all maturing, they're all valid. It really ends up being what makes sense for what you're trying to do. Some of them have more, like you can set up, it's relatively easy to set up a deferred system. It's not even that hard to set up like a tiled forward, but you got to dive into compute. And I don't want to say that's hard, I don't want to discourage you, you should do it. The fact is, if you want to do graphics work, no compute. Like, compute is the future. More and more things are moving to compute. Like if you look at consoles, I mean, GPUs in general, this is true, but like if you look at consoles, like Xbox to the 360 to the One. Our ability to render pixels to the screen has gone up, but not nearly as much as our ability to do ALU work, right? Like arithmetic logic unit work. So the bandwidth bottleneck for RAW is not going up at the same rate as the bandwidth bottleneck for ALU. So how does that make sense? Well, you don't actually go through rasterization. You don't engage the bottleneck of RAW through compute. Like hardware is pushing more and more towards the more things that you can do with compute. Like the more you can push, the only thing you actually really rasterize and draw to a texture traditionally through a pixel shader is your final present buffer, the more performance you're going to get. And that's probably not needed anytime soon. So you do yourself a huge favor if you figure out how to work with compute. If you figure out like, because the likelihood, once you graduate, if you get a job as a graphics programmer, the likelihood that you have to write your engine to deal with compute API and your shaders to do compute-based operations is high. So I highly recommend it, but it's one of those things where it'd be easy to be like, I'm gonna do that. Your student game probably doesn't need the power of like writing a separable pass filter for all your post-processing and compute. You probably don't need that. But it is really cool. Like, if you're into graphics, that's probably something that will speak to you. It may not be the best use of your time, like what you need versus what you want to do, but it will, at the same time, that will be an amazingly useful, I think, preparation tool for getting out of this place. Just kind of, meandered on that. But that's kind of a thing, because it's like, you gotta balance. The stuff that you're gonna do here is important. Like, you gotta learn. There's a foundation you build on, and then you learn some, you do more. You've gotta build your games, because you gotta pass your classes. And you also wanna make something cool, and I get that. But the stuff that's important to know for getting a job and then doing that job versus the stuff that's important for building whatever game you're gonna build here and getting it like ready by showcase, so you can get up and give a presentation and show up on the game gallery, are at odds with each other. And I'm not telling you not to try to make something awesome and to not like try to make everybody be like, oh my god, your game's amazing, and go to competitions and like win them. That's awesome. But I will say, speaking as somebody whose game never even ended up on the televisions inside this school, not because I don't think they're good, but whatever. The school clearly disagrees with me about the quality of my games. But it's not even like I went to competition or I won awards at Showcase, like literally never on the televisions. And that's fine. I was bummed out at the time, but that's fine because, you know, at the end of the day, that's a lot less important after you graduate. What you actually spend your time to learn and prepare yourself for the skill set that you do need outside of this place is far more important. They don't, like, those things can mesh very well, but they don't necessarily have to. They can actually very much be at odds. Sorry, that ended up being a weird tangent, but compute, learn compute.
That's good advice. That's the end of my questions. Do we have any other questions people want to ask?
Yeah.
Alright, one. So it was thanks for sharing your stories. Obviously, how you had to like deal with graphics debugging, but for cards for different hardware sets. But assuming it's on like a laptop and you can't actually swap things out, what would be the first step to getting?
Well, I'm not saying that you just swap cards out, but it was like, so like during my internship at Blizzard, it was kind of a thing where I got a bug about this issue that happened on one level, specifically if you used a Radeon X800. At the time of my internship, which was 3 years ago, this card was at least 5 years old and it had been a budget card when it came out. It was garbage. It was clearly not the GPU that actually was in my development PC. So I could not, and there was a system in place to try to get the engine to behave behave. So like, and the card was a shader model 2.0 card, right? So there was a system in place to get the engine to behave in a shader model 2.0 path. So I tried that first. It didn't cause me to repro the issue, so since I couldn't repro it, I hit the point where I'm like, I need to be able to repro it, so I had to put the card in my computer to do that. I don't recommend just like swapping cards around and be like, what works? So laptop is an interesting case. I totally didn't think that a lot of laptops will have a mid to low range Intel integrated card, and then they will have a discrete NVIDIA or AMD GPU. And then what happens is that there's a weird wire up that makes that work, and then there's software like NVIDIA has Optimus, and I think AMD's is called Crossfire. But it's part of their driver package that allows that whole thing to work, and the idea is that like you can set which programs will just go through your integrated card and which ones will go through the discrete card. But also it's designed to like, under low stress situations, just use the integrated card and then like kick in the dedicated card. Like, and they don't work flawlessly in a lot of cases, but so some interesting things I found, and this also might be part of it, is that you actually, in those setups, you may not actually, your device may not be set up on the card you think it is. So for example, my laptop, junior and senior year, yeah, it was an Optimus setup where I had like it had an integrated like Intel HD 4600, but then it had a discrete NVIDIA 7800M, or yeah, 780M, right? And so what I found though was that like I'm building my renderer, and I was trying to query the device and enumerate all of my displays and adapters, and it's like you've got 2 adapters, but one of them is blank, and the other one is your Intel card, and there are 0 displays. And I'm like, what? And this was really bizarre, and it was a result of NVIDIA's Optimus, the Optimus technology and NVIDIA's driver hijacking the thing to make the multi-card setup work. And so, like, I had to do, so originally I just did some really weird stuff that made it work, but I knew it wasn't right. Like, some of the stuff you're supposed to do where you're actually supposed to, like, enumerate all the settings for, like, resolutions and refresh rates and stuff, and actually use those values as input. I'm like, no, I'm just going to hard code some values because I can't get this information. What I found when I looked through the documentation is there's actually a way that you can tell the Optimus technology, for example, force the Intel card on, or the NVIDIA card on, right? And once you do that, all the like the IDGX factory stuff to enumerate adapters and displays suddenly works. So by default, if you just, and it was like you extern this value with this variable with the value, and then it turns on. And by default, if you don't do anything, it just forces it to use the NVIDIA card. But that's not even the end of it, because at that point, the enumeration all works correctly. Then you can be like, no, use the Intel card. I just wanted to get all the information. So step 1, I would make sure that your laptop, sorry, rambling a little bit, but it's kind of, it was a big actually thorn in my side for a while. A number of us, because a lot of laptops nowadays have that dual card setup.
The laptops in question, 2 of them had the exact same settings. So this is actually super helpful.
Yeah, so there's like a 3-page PDF on NVIDIA's website, but I can dig it up. I feel like somebody has actually posted it to the Facebook group too.
Okay.
But it's something like you extern this variable called like NV Optimus enablement, and then it has to have a value of like 0x00001. And then when you do that, suddenly when you run your engine, like your fan is really loud, and it's like, oh, now I'm on the Intel card. And so in that, okay, so that's actually an interesting thing, because what happens is, like depending on how old the laptop is, it's possible that even though you have this NVIDIA GPU, that you're running on the Intel card, and maybe that Intel card does not support the entire feature set that your NVIDIA card does and that you target your engine to. It's very possible.
I know the secret. So a DigiPen, you can just go to the IT department, they can hook you up with a machine, test machine. They'll even put it out in the labs. Like, this machine is configurable. You can swap out the thing.
Alright.
Yeah. So just, if you really have a problem, it's like, well, my teammates have this card, I don't. And I mean, I need to get this up and running. you can go talk to the IT, and somebody can get you a card that you can use. It'll get probably set up a machine.
Yeah. The only tricky thing is I haven't been able to repro this on PC. Like
Well, because most like desktops don't.
yeah.
If they have a multi-card setup, it's like SLI. It's not like it's not like here's your crappy card, here's your good card. Guess which one's running? Right. So it totally makes sense that if that might be your issue, and that's why you probably are never going to reproduce it on the
That's
desktop.
really helpful actually. So that's probably the best answer I've gotten.
Because yeah, like in the early version, what I found is it's like adapter 0 was the Intel card and adapter 1 was the NVIDIA card. I just couldn't get adapter 1 to actually show me information. But I'm like, but based on the tech specs, my card supports these resolutions. So I dug up, because part of the query is you can get vendor IDs, and they're like hex values, but each vendor has an ID. And so I had a white list for like vendor IDs, and I'm like, if the vendor ID in slot 0 is Intel, skip slot 0 and go to slot 1, and we'll just throw this resolution at it and hope for the best. And then when I found the whole thing, X turned the variable and actually turned the card on, I could change that. But the early days to make it work, because I was like, I wrote this whole thing, and like I threaded it out, and like I did all these optimizations, and I'm running at 30 frames a second, and I didn't understand what was going on. And then it became very clear to me what was going on once I realized it was running on my Intel card. So.
Okay, so an observation, you listed a bunch of graphics debugging tools. Similar to Insight for NVIDIA, there's an AMD tool which is called CodeXL, which is built based on the old G-debugger.
Okay.
It's outdated, it doesn't get updated anymore, but CodeXL does.
Right.
So if someone has an AMD GPU, CodeXL might help you.
Yes, and actually, so that's a good point. And CodeXL partially replaces, what was it called? They used to have a tool, I think it's called Shader Analyzer. So it only worked up through like DirectX 9 and some version of OpenGL that I don't remember because I don't really deal with OpenGL. But it was interesting because you could like write a shader in it, and then you could look at what's the D3D assembly that would be generated. And then for AMD cards, you could be like, what's the IL that, so this pixel shader turns into this D3D assembly, turns into this IL for each of these cards. You can actually look at the byte code that would be generated and consumed by the various cards that they produced, and that was really useful. And then they stopped supporting it, and CodeXL replaces it. But CodeXL only works, the CPU aspects only work if you have an AMD CPU, and the GPU aspects only work if you have an AMD GPU, as far as I can tell, because I have neither on my PC, and I can't get CodeXL to do anything, and it complains that it doesn't have these things. But so that's good. If you have an AMD card, CodeXL, and it integrates into a Visual Studio, could very well work for you. And I wish, because it was an amazing tool. I didn't have to know anything. Like I didn't have to know anything about my actual hardware, shader analyzer. Like I could just write pixel shader, and I could see what the assembly was. So I could actually compare, like, if I want to do like texture rotation, what's the difference between like actually creating like a 2x2 matrix and doing like the basic rotation versus what if I just do this series of like adds and subtracts, and like what's the byte code, and then I was like, this is less cycles. That was great, but that only goes so far since it only supports like pixel shaders and vertex shaders up to 9. But if you have an AMD GPU, in theory, you can do that functionality with CodeXL. So if you have an AMD GPU, I actually recommend CodeXL because theoretically it has really amazing features. I've just never been able to use them.
Okay, so now an actual question.
Yeah.
So you said that your job is writing shaders.
Yes.
Does this mean that you work exclusively in shader code?
Yes.
And so
Well, usually. It depends, but usually.
So let's say you're sat down with an artist, and the artist says, okay, I want to do this cool effect where the surface does this really neat and complicated thing. You figure, okay, I can make that happen, but I need the engine to give this extra piece of information to my shader to make it happen that it doesn't so far. So do you, at that point, do you have to sit down with someone on the engine side and be like, can you make it so that that piece of information gets to me?
It depends. But, I mean, so what I'm going to say, of course, has a caveat, because like there's a limit to how well. But the way that our engine is set up is actually relatively flexible. It essentially, we have an API for building so for like a material, the way that we store that information actually gets parsed out of the shader. So if I write a shader and I declare texture or float or int or bool parameters, the reflection system actually parses the information out of the shader to build the structure for the material. So within the framework that we have built, I can declare anything I want and the engine automatically updates to provide me that information. Now, it is really cool. And it works while the engine's running. I can while it's running, I can make a new shader and I can plug that shader into a material, and then it updates onto my PC and onto my Xbox. It's really cool. There are things that any piece of tech, there are awesome things and there are not awesome things, and sometimes they're like there's some things I can't get without actually changing the engine code. So like if I actually want to somehow get the game buffer in PS, if your effect requires you to use the game buffer at the time that you're rendering the game buffer, you maybe want to reconsider what you're doing, because there are terrible performance implications. But like for example, that kind of thing, I would have trouble getting. Like I would need to explicitly set the engine to give me that, because like when I'm looking at the fields for my material and I go to plug in textures, how do I plug in the dynamically generated texture at the time of this frame? That's not a file somewhere that I can plug into that slot. So like I would need to set up an explicit thing for that. And in some cases we do have, so essentially we have kind of a couple of different systems. And so for most shading that live within that framework that only need the data that we can provide through that automatic reflection-based engine hookup, and that's most of them. There are those, but there are some shaders that are very explicitly authored to do something, that have very explicit engine hooks that have had to be authored, and like they can potentially only work on explicit content types. Like you can't just be like, this shader is cool, let me put it on this thing. It may not work, but those are few and far between. And yeah, but what I can do is pretty flexible. But the amount of engineering work that went into building that, I think, was pretty immense. Like that's not the kind of thing that you're ever going to build here, as cool as it is. Like, hey, shoot for the stars, but.
So you talked about the communication that you do with artists in single day phases. So I was wondering about like performance-wise, when you there's only a certain amount of things like that you can create with shader before you every time the artist wants something, and you run to the point where it's like, well, if I add any more things that people want, you can potentially hinder the performance. What's the communication between you and a graphics dev who works on like these type of things, that manages the performance gain, like the things that you want to do, and how much time availability that we can actually support frameworks?
So I actually manage the performance in that aspect. So sometimes it will be just we can't do that. But it usually won't be the end of the conversation. It'll be like, we can't do that. So like if we so it's like they're like, I want this, but I want to add this thing. And I'm like, okay, that's too much. But if we take this and we add this thing, what things are you cool with losing from the original thing? Is there anything we can pair out to make room for this? That's usually what happens. Because yeah, that does come up. I mean, we hit limitations. We cap out stuff. And then like within the framework, like it's possible that the framework be extended, but there's a reason that there's a limit on how many texture inputs you can tell a material it has. Now we could just increase the number, but there's a reason that limit is what it is, and if you start going much higher than that, it's a bad idea. So it's just kind of, it's where it is to just be like, oh, we're at the limit, you can't add more textures, so if you want to add a texture, we're going to take one out. So it becomes an easy conversation to be like, but that's the limit, that's the limit. So, so a lot of times so there'll be stuff like, it's a conversation about compromise, and give and take, and like, if you get this, what can you afford to lose? Sometimes it's stuff like, okay, well, you know, this version, we were storing like the base normal map as like a DXTN, the full 3-channel DXTN. We could recompress it as like a BC3 in linear space and like only store the X and Y in the red and green channel, and then we could store 2 other pieces of data in the other 2 channels. But knowing that what you just did is that you increase the banding, because you have to reconstruct the Z and you store it in 0 to 1, so you got to range expand, which means that you introduce some slight banding. Depending on the application, that might be acceptable, but that's like a thing that often comes up. It's like, well, can we repack the way the textures are, and for stuff where you don't need the full channel precision, that it's cool to introduce banding or repack it. And sometimes that's part of it too. And then part of it is I just give them whatever they want, and then at the end I have to find ways to get the perf back so that we're in a shippable state. It kind of runs the gamut, but honestly, a lot of that, when artists create things that push the limits, that's on me to fix perf. I don't really go to the graphics engineers for that. But it depends. I mean, because it depends. Is the problem that like we're just pushing too much geo, and like render thread is just oversaturated, spending too much time culling? Is it spending too much time processing? Or is it like the pixel shaders are too expensive? A lot of times it ends up being the pixel shaders are too expensive, so then I have to, and that becomes my job. But like, you know, if other aspects of the render stack are suffering, then that either falls on the artist to figure out ways to change the content, or graphics might have to get involved. But it's more often than not, I've got to find ways to optimize the actual shading code. Yeah.
Custom, or do you use a tool for your shader reflection?
Custom. Yeah.
You're not using the reflection interface that comes with the
No. Well, but because it's much deeper than that. But no, it's completely custom, and it's actually pretty awesome. There are always going to be aspects. Like anytime you live in a code base for an extended period of time, especially when it's the kind of thing where hundreds of people have worked on it over decades, there are going to be things you hate. There are going to be things that people don't want to look at, and there are going to be things where like, this is really terrible code, but it functionally serves its purpose. This is not a performance issue, and nobody has time to fix it, so it just continues, right? That's the case anywhere.
Good word for that is corrupt.
Yeah. You know, there's always tech debt to be paid, and so we're definitely, and some of that technology is a couple years old at this point, and there are aspects that are not as great, but the basis of it, where like I write whatever I want, and then I compile it, and suddenly everything works around it, is pretty great. Yeah. I can't talk about it too much, unfortunately.
Understand.
But yeah.
I was just sitting here thinking about how much work would it be to actually write a parser for shader code, and it seems like
Well,
a good.
and so I will say in this case, what can help this thing, because you don't necessarily care about the code in general, you just care about the variable declarations, like your samplers, your texture objects, and then like your floats and whatnot. So part of the way that this gets handled is that we don't just declare them by themselves. Like if I want to add a float parameter, there's a macro. It's like declare float, and then I give it a name and all this stuff, right? So the macro expands in a way that for the shader compile, it makes sense, but then for the engine parse, it makes sense in a different way.
That's clever. And
Yeah.
not clever in the bad way.
Right. But yeah, so that's nice, because that's another thing, is that it'd be really easy to write a system, but that has to have data in like 2 places, and then it's really easy to mismatch. Because that's the other thing. Like I said, not every aspect of shading code in the engine falls under the auspice of this awesome material shading system. there are certain places where there, it doesn't all automatically reflect. There are some places where, like, maybe you have to write a new class for every effect you add. That kind of stuff. It happens. And that part's not great, but it all comes with the territory. But yeah, no, that kind of system though, like that's amazingly useful if you could manage to write it, like in the time frame here at the school, right? Like your project would benefit immensely, but like the amount of time that goes into actually building it and then making sure it always works, because yeah, like that's so unreasonable. Like there are still aspects, and I look at the source code. There's still aspects I'm like, how does this work? Right? It's a complex thing, but it is very cool. And but it's also the kind of thing where I think most like top end AAA professional studios have some version of that, because it's unreasonable to expect to shut everything down. Like nobody's iteration cycle can involve like shutting down the engine and recompiling it every single time. Like that's insane. Although that is the reality of shaders in StarCraft 2. But what they're able to get out of that, what they sacrificed by making that a reality, they gained a lot of other really cool stuff. Like they have like an auto permutation system. So they use that Uber shader approach where like you have like a couple of base source files, but they're littered with a bunch of if-defs that turn things on or off. But their system, so inside the engine, they treat shaders as first-class citizens. So it's this whole thing where they built a reflection system to automatically compile all possible permutations, put them all together, and so what happens is, yeah, like an artist in Max is like, I want, like they're just checkboxes, and they just check a couple boxes, and based on checking those boxes, it links them to the correct thing inside the shader bank. And it's all automatic. So from an artist perspective, it's amazing. But from an engineer's perspective, if you want to make a change, it's got to recompile the entire permutation matrix, and it's like at least an hour of your life. But it's kind of like a plus minus thing, right? Like engineer's life sucks. So like there were a number of times when I was there and I was like, I could do something, but I don't want to like sit on my hands for an hour plus. Is there a way I could do this without changing the shaders? So like I ended up in situations where I came up with some creative solutions to changing the data being fed to the shaders without actually changing the shaders themselves to get the same result. Because like, it was an internship. I had 3 months, I had limited time. I can't like spend a week making 10 iterations. Like that wasn't gonna work. So I had to figure out how to affect change more quickly. But but from an artist's perspective, it's like if the possible permutation exists, they don't have to worry about it. It does exist. And nobody had to manually be like, yeah, we can do this and we can do this, so why can't we just do this? Like it all just works. But the downside is, yeah, that long engineering recompile time. Of course, Unreal has the best of both worlds, but that's because they built 2 engines.
We should just build all our engines as 2 engines.
Yes, clearly. Well, it's kind of like the thing. So, like here at school, a lot of people, maybe this isn't the case, I don't know, it's been a couple years, but like a lot of people, what they would do for an editor is they would just build a toggle into the engine. So while you're playing, you hit some key combination, you open the console and type a command, and now you're in edit mode. And that was common because that's easy, comparatively. But, my junior year, I really pushed to have us go the other route where we actually built a separate editor. So we use like WX widgets, and so we built the editor as a separate executable that embedded our game inside of it. And the reason I pushed for that is because the previous 2 years I ran into 2 major problems constantly, and that was the stability of the editor was reliant on the stability of every aspect of the engine. Whereas, you know, by separating them, like graphics still needed to function, but like if there was something wrong in physics, that doesn't necessarily affect your editor. If there's something wrong in audio, that doesn't, if you did it right, that doesn't affect your editor. You can have instabilities and aspects of your engine and you can still edit. It doesn't stop content creators. And then the other was state management. I could not tell you, like in my sophomore project, how many times I'd go into a level, go into edit mode, but forget that I started the level and I walked forward and I pushed this block, and then I went into edit mode and I made some change in level, but I didn't mean to move this block. It just happened while I was playing. And so by having it just be an editor, and you make your changes, and then when you're happy, you can like launch the game from the editor, that fixed those two problems. And that actually, I think, worked out for us, but there was considerably more engineering time that we had to invest up front to achieve that. But it's always like one of those things, like, you can get something up and running quick, or you can spend more time and get something done better, but then, you know, depending on your time frame, like, you may not have the time to make something better, so I don't know, but like Epic's like, we just made like billions of dollars off of Unreal 3, so let's take some time and just, right? Of course, they had a lot of that type in 3 as well, but the idea, because like, you know, you're just like, here's a node graph, and I'm going to connect a couple nodes, and I already have my shader, and here's my preview, and it already works. But then, of course, that's not like fully optimized down, and you know, when you go to package the thing for ship, they actually go through a lot more validation processes and re-optimizations, and so, but that's two paths. That you had to spend engineering time to build two systems and to make them work together. If you've got that time, you should do that, because those kind of tools are amazing. Like, wherever you work, whatever engine you work in, there will be some aspect of that engine that at least one person is like, it'd be great if this worked like that. Always, right? But it's always going to be a matter of engineering time. And it's like compounded engineering time, right? So, it comes down to usability. A lot of times it always comes down to, like in our studio, it's very, very centric to artists. So like we try to balance it, and like we've got a more or less decent balance. I would like my iteration times to be faster, but artist iteration times are like, that's what's important, because it's all downstream, right? So you got like the actual like graphics engineers building the renderer, and you got me, but then you got artists, and it's like, well, if I do anything bizarre, I break artists. If graphics engineers do anything bizarre, they break me, which breaks artists. We have to make sure that we never block downstream. And so, so iterate, like, quality of usage and quality of iteration speed also follows that whole downstream idea. So it's more focused towards the artists, and then it kind of gets to me, and then eventually it gets to them. Different studios make different choices. But yeah. I'm now trying to remember what the original question that was all based off of was, but
Oh, that was based off of my comment. We should just build two systems
yes.
all the time.
Yeah, you should. Like, it's probably going to be best. You just probably don't have time for it. Because it's probably not going to be two systems. It's going to be two systems, and then you've also got to figure out how to make those two systems coexist together and always choose the right one of the two systems you're going to use based on the situation presented. Like, there's a lot more than two systems, right? But in an ideal world, yes, we would always build two systems. Because the fact is, the way that you iterate is very different than the way it gets played. And like the way that I iterate is going to be very different than the way that like any of my artists are going to iterate. And the fact is that I've got like environment artists, and I've got character artists, and I've got lighting artists, and they all actually have different ways that they iterate, right? So now it's like, what? Like, it would be cool if we got 5 versions of this tool, right? But that's not reality, so. But in a perfect world. Yeah. In a perfect world where I could just work on it forever without worrying worry about people needing to use it.
Yeah, or having to make money.
Yeah. Well, you know, it's interesting because, you know, it's the idea that, like, it's tough when you're developing the tech while it's being used. And that's the situation here. And it gets a little better out there. It depends on where you're at. But a lot of places still are like, you're still developing the tech as you're consuming it. And then, you know, but there are some places that are like, we've got a technology group, and then we've got the game group. But then it's interesting because if you look at like Crytek is set up like that. But if Amazon hadn't decided to build their engine on CryEngine, Crytek was in big trouble, right? So, of course, it's working out for Frostbite, so you know, it's kind of all over the place. But most places aren't set up to have like a technology group that can just develop whatever they want as they want, and then just be like occasionally, here's a library, good luck, guys. But if you can, I mean, that's great, right?
All right, so I think we're at the end of our time.
Yeah.
So thanks for coming by. and
Yeah.
chatting with us.
Hopefully you think that was useful.
I'd say probably most of it.
What?
We talk, and I'm just like, oh, I want to talk so bad. I want to say things so bad.
It's like all my information is Mike's information.
I'm just sitting here, I'm like,
That format was pretty good.
I'm like,
Format.
oh, that
Yeah.
format, dude, what a great